All right, let's continue our review of our meta quiz. So we have discussed the topic about coefficient of determination and the relationship between sample data, the standard error of the estimate, and R square. Okay, and what is the relationship if you delete some or you add some data with small residual and with big residual. So that's how this all these quizzes are focused on, and then we'll continue to talk about the relationship between correlation and R square. All right, so let me just add a number here. So 1, 2, maybe 3. Okay. So let's talk about the relationship between the dependent variable and independent variable, x and y. Say that you are facing with only the simple linear regression, which means that you got something like y equals to ax plus b, something like that. Or you get the fx, whatever. So you only get one independent variable, x. So if you got the function like this, and there is a relation between x and y. So if you want to know the relationship between x and y, the first thing is the relationship, that is the correlation between x and y. So if you see some words like correlation, you immediately know that you are calculating the correlations like this. You use the covariance of x and y, right? And you use the variance x, multiply that by variance y. So that's how you calculate the correlation. Of course, the correlation can be 1 and -1. Okay, so that's how you calculate the correlation. You can use the basic method, and of course you can use a different method, which is from the perspective of R square. So let me just give you how to do that with R square. Right, so why am I adding a why am I adding a thing here? Let me just let me just use this. So if there is just a simple linear regression of just x and y, okay, and if you are told that the R square is a certain number, you can use that number to calculate the relation between x and y, because that's how it's defined. Okay, so you use the square root of the R square to get the absolute value of R square, of the relationship between x and y. And you use the slope coefficient to decide whether it's a positive or negative number. So let me give you just some random example here, and let me get you my calculator. Right? Let me just give you a calculator and give you a random number. So say that the correlation is 0.8, and you square that, which means that you use 0.8 multiplied by 0.8, you got 0.64. Okay, so the R square of x and y is 0.64. Okay, so that kind of means that the x explains 64% of y's variance. Okay, that's how the relationship. And say that the relationship between x and y is something like this: y equals to ax plus b. So I want to know the correlation between x and y. How to do that? We just use the square root of 0.64 and we got the 0.8, and that is not the actual result of x and y. You need to make the judgment call by look at the a here. So if the a is positive, the correlation of x and y equals 0.8. And if the a is negative, the relationship between x and y equals to negative 0.8. Both are correct number. So that's how the mind flow of all this kind of problem that works. You first make your judgment call of what is the r square, and you use the r square. You square root that, you got the absolute value of a correlation, and you use the slope to make your judgment about whether this slope is positive or negative, and whether the relationship will be positive or negative. And that's how these problems are worked. Okay.